Okay, today we'll be learning about ratio and proportion. Many times we come across comparisons. Say, for example, you got 28 marks in an exam and your friend got 42. Then your friend got 40 marks more than you. But sometimes a difference cannot be a criteria for comparison. An example of this situation would be if you both give an exam of 20 marks where with 4 questions, and you got three questions right, and your friend got four. So you would have gotten 15 marks, whereas your friend would have gotten 20, which gives you a difference of 5. And in the second exam, which has a score of 10 and a total of 5 questions, you get all 10 right, but your friend doesn't get 2 right. So in this case, your friend would score a total of 6 marks, whereas you'd score 10. Now the difference over here is 4, where you got all the questions right and your friend got 3 questions. Like you got 5 questions right and your friend got 3 questions right. So in the first case, you got 5 marks lesser than your friend. And in the second case, your friend got 4 marks lesser than you. So it seems like you did worse than your friend, right? But when you think about it, you got only 1 question wrong in the first paper. And in the second paper, your friend got 2 questions wrong. So in cases like these, you cannot use difference to make proper comparisons. For another example, say the height of an elephant is 25 feet and the height of a man is 5 feet. Here, ratio makes more sense compared to elephant. We can say that the elephant is 5 times the height of a man. Basically, ratio is nothing but a division operation to be performed between two numbers, and the greatest common divisor is 1. The greatest common divisor being 1 implies that you cannot simplify the ratio or the fraction any further. So now we have an idea of what is a ratio. So let's quickly try to solve a problem. Raju has 300 chocolates and his friend Ramu has 100 chocolates. Find the ratio of chocolates between the two. So like I said, a ratio is just a division. So all you have to do is take 300 chocolates and divide it by 100, which leaves you with a ratio of 3:1. So the representation of a ratio is a colon between the two numbers, and it's read as 3 is to is to 1. Here's another example. The length and breadth of one rectangle are 6 and 8 respectively, and the length and breadth of the second rectangle are 12 and 4 respectively. So what is the ratio between the areas? So first, the formula for the area of a rectangle is L into B, length into breadth. So 6 into 8, you get 48, and 12 into 4, you get 48 again. So when you divide them, you just get the ratio as 1:1. So both the rectangles have the same area. Give two equivalent ratios of 16:8. Now here's an example of a ratio which hasn't been simplified, which means that the highest common factor between these two is not 1. So 16:8 can be further simplified into 2:1. So two equivalent ratios, what they've done here is they've multiplied both 16 and 8 by 2, which doesn't change the ratio but gives you 32 by 16. And in another case, they've divided both the 16 and 8 by 2, which leaves them with 8 by 4. Note that none of these ratios, the equivalent ratios, are also simplified. You can have only one base ratio, and all other equivalent ratios do not have a common factor of 1. Ratio of distance of playground from Ramu's to the distance of ground from Raju's house is 4:3. Both of them start at the same time. Who will play first in the ground? So the distance from Ramu's house is say 4x, and the distance from Raju's house is 3x. So if you assume x to have a value of 1 or any value 5 or 10, you'll always get that 4 is greater than 3, which implies that Raju will arrive at the playground first because his house is at a smaller distance away. Proportion. Now let's move on to proportion. Let us consider a case where you want to finish shopping in the cheapest way possible. Like you want to spend the least amount of money that you can possibly spend. There are two shops where you need to purchase items from. In the first shop, 7 items are sold for 42 rupees. And in the second shop, 6 items are sold for 30 rupees. You have to buy the fixed number of items. So this means that in every shop, you have to buy, like regardless of which shop you go to, the number of items you buy has to be the same. So in order to sacrifice items for money, where will you buy? So the solution to this problem would be, in the first shop, the cost of every item is 42 by 7, which is 6. You're dividing 42 by 7 here because you have 42 rupees and 7 items. So what will be the cost of one item? That's just 42 by 7, which is 6. And the cost, similarly, the cost of each item in the second shop is 30 by 6, which gives you 5. So clearly 5 is lesser than 6, and hence you would rather shop from the second shop to save money. Proportion and ratio go side by side. That is, if the two ratios are same, then we say that they are in proportion. In a state of proportion, first and last values are called extreme terms, and the second and third values are called the middle terms. Are the following numbers in proportion. So what you have to do is take the first two numbers and divide them together, and similarly take the other two numbers and divide them together. If they were equal to each other, that would have been called being in proportion. As you can see here, clearly the ratios of the first two and the last two numbers are not the same, and thus these numbers are not in proportion. Do the ratios 15 minutes to 1 hour and 10 centimeter to 0.4 meter form a proportion? So in order to form a proportion, like I mentioned, both the ratios need to be equal. So we need to find the ratio between 15 minutes. So we need to find the ratio between 15 minutes to 1 hour, and we need to find the ratio between 10 centimeter to 0.4 meter. So 15 minutes is basically just 1/4 of an hour, which gives you 1/4 as the ratio. And similarly, 10 centimeter gives you 10 by 40. Once you convert 0.4 meter to centimeter, you get 40, you get 10 by 4, which is 1/4 again. Hence, even though these items are not of the same type, the ratios turn out to be the same, and hence these items are in proportion. Note that a ratio does not have any units. You can only divide you can only find ratio between two items which are the same type, like they must have the same unit. Like you cannot find the ratio between time and distance. If somebody asked you the ratio between 1 hour and 40 centimeter, that would not make sense because they're not comparable, and finding a ratio for them doesn't make a lot of sense. Unitary method. So as I mentioned before in a previous question, like if you have 42 items and 42 rupees and 7 items, what's the cost of one item? That is exactly what unitary method is. So as the name itself describes, unit means one, which says what is the cost per unit. Rajiv buys 4 liters of milk for 48 rupees. What is the cost of milk per liter? So 4 liters is 48 rupees. So 1 liter would just be 48 by 4, which is 12. Hence the cost of 1 liter is 12 rupees. Here's another example. For moving 10 kilometers, a car requires 4 liters of petrol. For moving 5 kilometers, how much petrol does the car need? So all you have to do is find out how many liters of petrol a car will require for 1 kilometer, and then just use that information to find out how much a car moving at 5 kilometers would require. So for moving 1 kilometer, car requires 4 by 10 liters of petrol, which is so for moving 5 kilometers, the car requires 5 into 4 by 10, which is basically 2 liters of petrol. A simpler way to do this particular question would have been, since 5 kilometers is just half of 10 kilometers, you could have said that you will only require half the petrol. So 4 by 2, which gives you 2. A cycle moves 60 kilometers in 2 hours. How many hours will it take to cover 480 kilometers? So time taken to cover 1 kilometer is 2 into 1 by 60, which will give you 1 by 30. So as an additional exercise, you can try finding the speed of the cycle, which is just distance by time, which will come out to be 30 kilometers per hour. So that brings us to the end of this ratio and proportion set of slides. So yes.